Alright, so now we understand what this means, right? 6 to the 1/2 is just the square root of 6, or for example 7 to the 1/8 is just the 8th root of 7, and so on. And the next step, the next logical step, is to go one step beyond and ask about what 6 to the 2/3 could mean, or 7 to the 4/8, or any number, I don't care what number, to any exponent, any fractional exponent could mean. Okay, and we're gonna go into these things right now. Okay, so we have proven already one thing, which is that a to the 1/n is equal to the n root of a. And I hope that the proof was understandable. And okay, now I'm gonna prove now two things: that a to the m over n is equal to the n root of a raised to the m, and the third thing, I'm gonna prove that a to the m over n is also the n root of a to the m. So you can see, you can understand this symbol a to the m over n either in this way or in this way, both of which are exactly equivalent. Okay, it doesn't matter which one you choose, it doesn't matter. Actually, the only thing that is different from them is the placing of the m's, but they are exactly the same thing. Okay, so first I'm gonna prove the second fact. Okay, so let's write in here demonstration number 2. And in order to make that demonstration, I need one of the laws that we know, which is that a to the m to the n is equal to a to the mn. Okay, we know this, and I'm gonna use it in a moment. Alright, so demonstration of 2. Here we go. All I have to do to prove this fact is the following. I'm going to write a to the 1/n. I'm going to write this number, and I'm going to raise it to the m. Okay, so let's raise it. According to this law, I can write this as a to the 1/n times m. Make sure that you understand why this is equal to this according to this law. I'm going to give you some seconds for you to understand. Okay, I hope it's very clear for you why this is the same as this. Okay, let's continue. This is equal to a raised to the 1/n times m over 1. I'm just rearranging the way in which I'm writing the m. M is equal to m over 1. And if I multiply these two fractions, I get a raised to the m over n. Okay? So basically what I have just proven is that this is equal to this. So in other words, I have proven that a to the m over n is equal to a to the 1/n to the m. Okay, but if you remember, this number inside the parentheses is nothing but the n root of a. Okay, so the proof is complete. The proof of number 2. Can you see? I have arrived at the same thing. So the proof is completed. Fine. Now, I'm gonna demonstrate the third fact. It's much simpler. The third fact is this: a to the m over n is equal to the n root of a to the m. And this is in fact much simpler. All I have to do is this: I'm gonna write this number a to the m, and I'm gonna raise it to the 1 over n. Okay, so basically I'm raising a number to the 1 over n. So I can use this first fact. If I raise a number to the 1 over n, that's equal to the n root of the number. So in this case, by number, I mean all of this. This is my number. I'm raising this number to the 1 over n. So that's going to be equal to the n root of such number, which is a to the m. And the proof is completed. Can you see? Okay, because am to the 1 over n is the same as this, which is equal to n, the n root of a to the m. So the proof is completed. Okay, so whether you use this way in order to interpret this number or this way in order to interpret this number, both are perfectly fine. So let's go over to some examples. For example, let's suppose that we have 4 to the 2 over 3. You can interpret this as the cubic root of 4 to the 2, or you can also interpret this as the cubic root of 4 to the 2. So as you can see, the only thing that changes is the placing of this exponent. Another example: 13 to the 7 over 8. You can interpret this as the 8 root of 13 to the 7, or you can interpret this as the 8 root of 13 to the 7. Both of these things are exactly the same. Which way you want to use, it's up to you.